Right, let's just draw shear force. Well, I've just come back to one of these diagrams that we've used earlier. So we know RA, it's I think on this one it was 15, yeah, and RB is 55. So that's 15. Let's draw the beam in. I'm drawing this beam over here. We've got 40 kilonewtons acting down, that's 2 meters away. 3 meters to RB. That's 30 kilonewtons acting down, it's 2 meters to that. And RB is 55. RB, that's RA. These are all kilonewtons. To draw a shear force diagram, you have an axis of 0 shear, and then just imagine these being in line. You draw it to scale, or an app, or use a computer drawing package. But your shear force diagram, you've got 15 kilonewtons coming up, so draw that up 15 units. So if you're doing centimeters, you could draw it 1.5 centimeters, or if you like, if 1 millimeter equals 1 kilonewton, you draw up 15 millimeters. That would be 15 kilonewtons on our scale. Go straight across to your next point, and it's coming down 40, so drop down 40. So you were already up 15, and you've just dropped down 40, which means you've come down. This is going to be an equivalent of minus 25. So you've gone up 15, across, down 40. Now you're going to go across, and then your next arrow is this up 55. So you're going to go up 55. So you were down 25, and you've just come up 55. So if you like, minus 25 add 55 is going to bring you back positive 30. And then you go across to this final arrow down, and it closes bang on. It always starts and ends on 0, give or take. If you've got very close rounding from working out certain numbers, it might be slightly different, but usually you'll find that when you hatch it in. So it's showing that the beam wants to snap the most at this point and at this point, especially at this point because it's the longest snapping point, if you like, the longest line. Whether it's above or below the line is dictating. It's not too much of a worry for yourself, really. It's dictating whether the right hand side of the beam wants to go to snap below the left, or the left hand side wants to snap upwards above the right. So it's not too much of a worry. It's more of a concern when it comes to bending, which we'll look at next. So I'll just move over to this diagram here, and we worked out, in fact that's the same one, it's the one below that I'm after. Let's sketch this one on then. So without even knowing the shear force, the RA and RB results, it will look something like RA will go up, it'll go across and then down, across, then RB will come up and then across and down, and these will be in line with those. So drawing shear force is pretty easy, to be honest. However, I'm going to move on to drawing shear force for a UDL. So for shear force for a point load, you just follow the arrows around, and you've cracked it. We'll look at UDLs next.